Let me go ahead and share. Okay, good to be with you all. Good morning for those who still morning. Good afternoon, good evening. My name is Gabe Suddeth. I work at Corning. I'm the Multi-Core Solutions Program Manager. Just took over this role from my colleague, Dwayne Robbins, who you may know from other talks or industry meetings. So if you see him, he's moved on to something else here at Corning, and you can greet him next time. But I've been involved with Multi-Core for a couple of years now as part of our program, most recently managing our premium fiber product lines. But I'm here on behalf of the SDM4 MSA to give you a little preview, understanding of what multi-core is, what the problem it is addressing is, and then I'll kind of go through the questions, the lightning round questions. And I got to go lightning speed because I think we're a little over time. So I will go fast. For those who don't know, multi-core fiber really is just what it sounds like. In general, you're taking one single core fiber. Right now, it's kind of a normal core. You can think of it as a 652, G.652 like core. You're getting it in the same cladding with multiple other cores. In this version I'm showing you here, this would be a 4-core fiber in a 2x2 arrangement. Don't think of this necessarily as the MSA spec, because I'll tell you on the next couple of slides, the MSA spec that we have for SDM4 is not yet published. So this is, you could think of this as a notional guideline, though you may have seen this out there in publications and other sort of industry papers. So 2x2 arrangement. Critical right now is the cladding is still 125 microns in most variations that you'll probably see in the next couple of years, but there's experiments and other wild things where you can get many more cores in a cladding, but you may have to change the cladding size or you got to change the core. So those are some of the parameters that you can play with in terms of designing optical multi-core fiber. You can set the core pitch. Also, in this iteration I'm showing you here, 40 microns, and so you have different impacts to your fiber performance depending on how you set that core pitch. But by and large, you have 4, I'll call them air quotes, normal cores in this kind of package, which really gives you up to 4x the bandwidth, the pathways in that thread of glass than you have in a single core fiber. So it really gives the next level and an unparalleled density advantage compared to other fiber solutions. Inside the data center, this is really a scale out play for now, and then even scale across into applications outside the data center. But the MSA is really focused on the scale out application. And there's really 3 main reasons. They're pretty obvious through our pictures here. Even number 1, multi-core gives you a density advantage that very few solutions can compete with. You get a 4-to-1 advantage. 4 cores in the same glass allows you to cut the amount of cable that you have in that scale out portion of your network down pretty significantly. So you take a cable tray that's full, or maybe, they don't necessarily get that full, but wherever it is in terms of how full it is or however many cable trays you have, naturally you can cut them down almost 4-to-1. Same with the number of connectors that are in that link, right? So you can take the number of connectors down significantly, still generally getting that 4-to-1 advantage. This is one of my favorite pictures that we have in the multi-core ecosystem, just showing all the cores generally rotated in a connector right there in the ferrule. And that's a significant reduction in the number of clicks the installers have to do. And it also gives you savings on that patch panel, which could free up space for another patch panel or something else that you have on the rack. And then third, just by cutting material out of the system, you're naturally providing a sustainability advantage versus just adding much more single core fiber, because you have a smaller cable, you have less material. That also means you have fewer trucks and transportation logistics challenges to get that same amount of material on site. So a pretty cool advantage for the world. Those are the 3 main issues that we're trying to solve with the MSA. This is actually my last slide. So short slide deck here. Why are we doing this? With the AI scale out, AI everything, right? There's just density constraints all across the network. And this is one portion of the network that we can address with multi-core fiber. The reason the members have moved forward with an MSA is really to get some synchronization in the industry faster than we will achieve through the international standards bodies. We love working with ITU, IEC, IEEE. We need worldwide international standards. The process just takes a little bit longer than what we see needed in the short term to really start to create the market adoption that multi-core needs, right? This is an ecosystem change. People, companies, network installers, field equipment providers, everybody needs to get comfortable with multi-core fiber. And we really need some level of an MSA to have synchronization on critical parameters, just so that there's some level of sameness in these fibers. In terms of scope, really the MSA will, when we release the spec, encompass a 4-core fiber that's good for O-band short reach applications. Okay, so less than 2 kilometers in this case. Now you'll see other demand for multi-core fiber in the industry beyond this, but that's kind of outside the scope of this MSA. We're probably a little bit behind where we thought we'd be in terms of releasing a spec. When we published a press release in March timeframe before OFC, we thought it'd be a couple months. I think from this point on, it'll be within a couple of months. So I'm kind of keeping that same tagline. And you can see the member companies there. We have AFL, Corning, Sumitomo, and TerraHop. I think the members' intention, as noted, as you'll see in the press release, is to release the spec. And then to go through the process of adding members. So we very much welcome other members. In general, you can see what the MSA is going for. We're not looking to stifle innovation. This is really fostering a market that doesn't even exist now. And to have that level of sameness so that you can even have the initial adoption of multi-core before the international standards process is done. But that it's moving apace, and we're pleased with the progress there. And then, of course, yeah, you can reach out if you know someone, one of these companies, reach out, indicate your interest in joining the MSA, and we're kind of working through that process. Similar to Drew's MSA, said they're still figuring it out. So we're in that boat. I'll stop there. That's kind of what I had. Dan, I don't know if you have any questions. Otherwise, I'll step back.
Just a quick question, Gabe. Thank you very much. Seems to be the real challenge here is coming up with a standard connector. How much of your effort is going into that?
I'll have to take that as a get back.
Okay.
Yeah. It's
Okay.
definitely, you know, there's some progress that needs to happen in the industry to standardize there. I think we also want to make sure that we'll be available in several connector types, right? Because not everybody's the same there either.
Sure.
But I can't recall if the MSA will have connector standards or not. So.
And, you know, we all face feature creep.
Yeah.
What are your thoughts on going to more than 4 cores?
I think it's a great question. I'm sure some people are like, why 4? Why didn't you do 8? Why not 19? You'll see 19 is probably the upper limit of what you can get in the cladding. I think there's general consensus that 4 is really the right place to start. 2 is too few to really get the bang for the buck. And more than 4, you start to have to really change the parameters of the optical properties of the cores beyond what's kind of normal, I'll say, and what people are used to now. So it could happen down the road. But I think in terms of fostering innovation, but not going too far such that you almost create adoption hurdles for, seems to be the kind of the sweet spot in terms of keeping performance where it is today while still getting the multiplier bang for the buck.
You know, that's valuable. Let's settle on something that's actually doable and brings a lot of value.
Exactly.
You know, you mentioned 19. It's not like a random number. I know a company that's doing microvixels, and they're looking at exactly a cluster of 19.
Yes. Yeah, and Drew brought that up. When you start VCSELs and micro LEDs and where the arrays might go, there's another area it's kind of ripe for that same kind of settle down on something so that we can start to actually innovate and create the supply chain that's needed for adoption.
Great. Thank you, Gabe. All right, our final one.